So today let's talk about E-Prf. Okay, so I'm sure you must have came across the terms like PRP, PRF, IPRF, APRF, injectable PRFs. Okay, so I don't want to go into the depth of what is PRP and PRF. So today let's talk about one of the advanced PRF, concentrates, that is a fourth generation PRF, that is extended PRF or albumin rich PRF. Okay, so we all know that we have four generations. The first one is the PRP, the second will be PRF, LPRF, APRF, third one will be IPRF, and the fourth one will be E-Prf. Okay, so see, I'll tell you a very important thing about PRF. Okay, so PRF, if you see, it has, the name implies, platelet rich fibrin. So it has a fibrin matrix around it. So basically why we do centrifugation is we are separating the cells based on the densities. Okay, so a rich fibrin network will be present which will release the growth factors over a period of time, and that is going to help in regeneration. That is the basic concept of PRF. Okay, so it varies on the speeds and RPM, so we get different types of PRFs. So in PRP we had anticoagulants, and in PRF we don't add anticoagulants. So the reason advanced PRF is called as a E-Prf. So one of the main drawbacks of a PRF is it has a very less resorption time. That is, it resorbs within 2 to 3 weeks. Although it releases a lot of growth factors, it resorbs within 2 to 3 weeks. Now, because of this reason, I cannot substitute PRF with collagen or any membrane, because any membrane, the ideal goal should be it should exclude the soft tissue to penetrate into the area, so that the cells which need to grow in that area will go, new attachment. Okay, so what, over a period of time, what they did is they found out that eating a PRF, so when I eat a PRF, there is some kind of process taking place, which I'll tell you what happens. So by doing this, the PRF resorption rate is increased. Okay, so the evolution of that PRF is called as the extended PRF or albumin rich PRF. Okay, so I'll tell you a very simple protocol of how the extended PRF or albumin rich PRF is prepared. Okay, so first we collect blood, the peripheral blood is collected. Nine to 10 ml of tubes. Okay, so I'm collecting the peripheral blood, and then what I'm doing, I'm centrifuging it at 700 to 2000 G or relative centrifugal force for 8 minutes. Okay, so once I centrifuge it at this speed, I'm going to get a PRF. So I can able to see the top layer will be PPP layer, and then I will have PRF, and then I will have a small buffy coat here, and then I will have the RBCs. Okay, so PPP layer plate, that is it will have a very poor plasma, platelet poor plasma. Below the platelet poor plasma we will have PRF, and then a buffy layer coat, and then the RBCs. Okay, so once I obtain this by by centrifuging it at 700 to 2000 grams or relative centrifugal force for 8 minutes, I am just taking the PPP layer. Okay, I am removing the PPP layer. Okay, and I am placing this PPP layer in a special machine which is called as the BioEat. So this eating part is very important, because it is the one that is going to extend the resorption rate. Okay, so I'll tell you how. So I'm eating it at 75 degrees Celsius for 10 minutes. Okay, I'm eating it at 75 degrees Celsius for 10 minutes. So I'm taking the PPP layer out of the obtained PRF. Okay, so the PPP layer is withdrawn and it is kept in a bio-heat machine and it is heated at 75 degrees Celsius for 10 minutes. What happens during this heating process is basically the albumin which is present in the PPP, okay, it will undergo denaturation. Okay, that is, it will change the structure without breaking the peptide bonds. So what happens, they unfold. So they unfold and they aggregate to form a gel and forms a gel. So albumin gel is formed by eating the PPP layer. So the albumin, it denatures, unfolds and aggregates to form a gel. So this gel is extremely resistant to enzymatic digestion. Okay, this gel is extremely resistant to enzymatic digestion. So that is why it has a longer resorption rate. I'll tell you how much or how many days or months it will come. Okay, so once the PPP layer is taken, it is heated in a bio-heat machine for 75 degrees Celsius for 10 minutes and then it is kept in a bio-cool device. Okay, you get a gel after this layer and then I'm keeping it in a bio-cool device. Okay, and then what happens, the remaining portion, that is the PRF, the liquid PRF and then the buffy coat and the RBCs, all these are taken and then they are mixed with this albumin gel. Okay, so this is a kind of an lever lock device, female layer lock device, so where they will be combining the gel with the remaining components of the PRF at least 10 times so it will mix properly. Okay, and then you get a perfect E-Prf. Okay, you get a perfect E-Prf. So the resorption rate of a E-Prf, if you see, it varies to 2 to 3 months. So now I can substitute this with a collagen membrane. Okay, so E-Prf has a resorption rate of 2 to 3 months, whereas a normal PRF has a resorption rate of 2 to 3 weeks. Okay, so this E-Prf, it releases a lot of growth factors, platelet derived growth factors, endothelial growth factors, transforming growth factor beta, and also it increases the fibroblast proliferation. Okay, so I can use it in cases of any augmentation procedures and I can substitute it with collagen because this has a resorption rate of 2 to 3 months. So this is all about E-Prf. It is one of the recent advances in PRF, fourth generation PRF, extended PRF. As the name implies, it extends the resorption rate and it is also called as albumin rich PRF because the albumin, it is the one that unfolds and it aggregates to form a gel so that it becomes extremely resistant to any kind of enzymatic digestion. So I hope this video makes sense. Thank you so much for watching the video. Have a nice day.